All right, good morning. I will review one of the question we did not finish last time. It was the skewness of gamma distribution question. So I went through the example one. I give you guys the question. Then I think not everyone have that finished. So I'll go through that question again. So the question is this, and it was the skewness of a gamma distribution that it's calculating the skewness of gamma distribution, that the gamma distribution actually has a coefficient of variation. The question example I give in class was 1. Then I ask you to do a question of, I believe it's the square root to 2 over 2. And asking you to calculate what is the skewness. So for this one, we're given coefficient of variation, CV. Coefficient variation is really standard deviation over mu, and where where mu is equal to expected value of x, and the standard deviation is really square root of variance, and variance is really expected value of x squared minus expected value of whole thing square. So if we're able to calculate the first and the second moment, we will be able to calculate the mu and the standard deviation. We will be able to match with the coefficient of variation. This actually help us to find what is the alpha. And actually the answer in this case is pretty simple. The alpha is 2, but I'm going to just go through this. In the formula book, the formula is saying the expected value of x to the power of k, if k is a positive integer, is equal to theta to the power of k, and alpha plus k minus 1, all the way down to alpha. This is gamma distribution. Actually, I feel like this was the old way they write this formula. The new way they write it, it's alpha plus 1 all the way to alpha plus k minus 1 theta to the power of k. They're actually the same thing. They just reversed the order of this. So for expected value of x, it should equal to alpha, and because k in this case equal to 1, because k, there's an invisible k here, if it's 1, therefore this is going to be 1, this is going to be 1. If it's 1, that means 1 minus 1 is 0. Therefore, this whole term become alpha plus 1 minus 1 is really just alpha. Therefore, this is supposed to be alpha plus 1, alpha plus 2, all the way to alpha. But because it's alpha, therefore, this become just one term, just alpha. And theta to the power of k, where k is equal to 1. Therefore, this piece is equal to alpha times theta. That's how to use the formula. And in this case, it's going to be alpha times theta. And let me get rid of the color. And now we want to calculate the second moment square. It's going to be alpha plus 1. And because when k equal to 2, in this case, k minus 1 is 2. So you will stop at alpha plus 1. Therefore, you will get alpha times alpha plus 1 times the theta squared. Now, you will have the first and the second moment. Then the variance. Let me extend this. There will be alpha squared, theta squared, plus alpha theta squared. And the variance is going to be e to the x squared minus expected value of x whole thing squared. And that is equal to, alpha squared theta squared plus alpha theta squared minus alpha theta whole thing squared. And this piece and this piece are the same thing. You end up with alpha theta squared. And standard deviation, which is the square root of variance, which you will end up with square root of alpha times just 1 theta. And because it's a given, and let me highlight this. This is actually formula. Let's continue with the work. And because we're given alpha over mu is going to equal to square root of alpha times theta over mu, which is alpha times theta. And let me give you some numbers. This is your mu, and this is your standard deviation. This is your standard deviation. That's where I plugged it, and that's your standard deviation. This is your mu. Same thing. This is the mu. This is same as mu. This is same as mu. This is standard deviation, and you get a standard deviation. Therefore, this is equal to theta cancelled. Therefore, you get a square root of alpha over alpha. It was given in this question. I made a question that's square root of 2 over 2. You can actually, if you calculate that alpha, it's really just 2. Because you find alpha equal to 2, thus expected the value of x in this case, which is mu, which is going to be just 2 theta. Expected value of x squared. Use this average. Right, this would be 2 theta. Let me write it one more. This is going to be alpha times theta, where alpha equal to 2 now. Then there will be 2 times theta. Yep. I'm going to use 2. This is your alpha. This is your alpha. This is your alpha. Okay. Now, expected value of x squared. You end up with getting alpha squared theta squared plus alpha theta squared. And because you know alpha equal to 2, therefore you end up with 4 theta squared plus 2 theta squared. You end up with 6 theta squared. And they are asking you to calculate skewness, where skewness is equal to expected value of x minus mu to the third over standard deviation to the power of 3. All right, so we're gonna work with a little detail. The relatively difficult part is how do we extend the thing on the top. You want to expand the thing on the top. This is the expected value, x to the power of 3 minus 3x squared mu plus 3x mu squared minus mu to the third. That's, you just extend it for the 3 pieces. All right, let me see whether I did this right. And standard deviation to the third. If I extend to the top, it's the expected value of x to the third. We talked about this e. Expected value e is really associated with x because x is the thing that changes. Therefore, whenever you see x, it has to have an expected value. But whenever you see anything else, those are considered as constant. Therefore, it's minus 3 mu expected value of x squared plus 3 mu squared expected value of x minus mu to third because it does not vary. That's what you have. And it happened to be that this is really just a mu. They're the same thing. The number is the same thing, expected value of x. So you end up with this is mu, that is mu, this is mu. They're all mu. These are all mu. Therefore, you can simplify what you have. Expected value of x to the third minus 3 mu expected value of x squared plus, now this piece, it has a 3 mu. So it's a 3 mu squared plus 3 mu squared, mu to the third, minus mu to the third over standard deviation to the power of 3. Okay, so expect value of x to the third minus 3 piece, this is 1, 3 mu expected value of x squared plus 2 mu to the third over standard deviation to the power of 3. This is a question really challenges your understanding of what is expected value, what is the constant, how do you extend it, and how do you calculate the moment. This is actually, you didn't calculate any moment because it's given by a formula. It's really, you plug in alpha times the theta and etc. You can get a formula. Now in this case, let's start using more colors. We need this. We have expected value now. We also have standard deviation now. We actually also have the second moment as well. And now we just need to calculate the third moment. If we're able to calculate the third moment, then we can plug in. We will be able to get all the results. And let me do a little bit extra work. Let me finish the standard deviation because now we actually know what is alpha. Alpha is actually a 2. So this is square root of 2 times the theta. This is our standard deviation. Okay, and we have standard deviation. We also have a second moment. We actually also have our first moment. This is a 2. We also have our first moment. We just need our third moment. Let's do the work for the third moment. For the third moment, it's equal to, apply to the formula, alpha plus 1. Now it's going to be alpha plus 2 now because k equal to 3, alpha plus k minus 1, k equal to 3 is alpha plus 2. You will stop at alpha plus 2. So k to the power of 3. And we also know what is alpha. Alpha is 2 in this case. 2 times 3 times 4, theta to the third. That will give it 2, 6, 26, 24. 24. Oh, what happened with my 24 theta to the third? And let me give it another color. Look at this, look at this, look at this. Now let's plug in. We plug in. We'll get 24 theta to the third minus 3. Mu is 2 theta. Second moment is 6 theta squared plus 2. Mu is 2 theta to the power of 3. This is the square root of 2 times theta to the power of 3. So this comes from the standard deviation. And this is our mu. This is our mu. This is our second moment. And this is our third moment. And you should realize they all have theta to the third. So plug in the value. You get a 24 minus 3 times 2 is 6. 6 times 6, 36. Plus, that's 8. That's a 16. Over square root of 2 to the power of 3. That will be 2 root 2. 2 root 2. You should be able to get, let's see, 4. 4 on the top. 2 root 2. 4, that's 16 minus 20, that's 4. Then that will be 2 root 2. That will be just a root 2. And your final answer should be root 2 for this case.